Hey everyone, welcome to this video, and today is a really special day because out of all my other videos to date, this is the one which I'm most proud of. Now, it's definitely been the most ambitious video that I've ever attempted. I've had to apply lots of animation to it. My animation skills aren't amazing, but hopefully I've done enough to put my point across. Now, a really cool thing about this video is it was born from suggestions from you guys, the subscribers. So keep those suggestions coming in of what you want to see next. Now, really quickly guys, before we get into this video, I just want to say, if you want to be confident to tune your tattoo machine and come away from this video with all the knowledge to tune in future machines that you get, then I can't stress enough how important it is to not skip any parts of this video. And the reason for that is because I've constructed it into 10 easy to understand bite-sized blocks. And each chunks of these information build on the previous one. So if you were to skip, say, halfway through the video, it might not make much sense to you because you haven't seen the previous bits of information. So just set 15 minutes aside, watch this video in its entirety. And also I've made this video so you can sit with your machine, actually follow me step by step through the video to get your machine tuned, and I'd really love to know who does that, and let me know how you got on with it and what a difference it made to your machine. My final point to make is, some people ask, why do I even need to tune my tattoo machine? And for that I'd say is, if you play guitar or anything like that, you could order literally the world's most expensive guitar and it come through the post, and then you play it straight out the box and it just sounds like a bag of crap. And that's because it'd need tuning up, it'd need tuning, all the strings would need tuning. And it's exactly the same with a tattoo machine. It needs to be tuned to get the maximum benefit out of it. So if you do like this video, don't forget to drop a comment, give it a thumbs up, subscribe to my channel. With all that said guys, let's not waste any more time and get straight into this video. So just quickly before we tune the machine, we're going to take a look at the main components that we're going to be focusing on. So we've got the armature bar there, we've got the front spring, the back spring, O-ring, and the front contact screw. So basically what we do is we take the armature bar, the back spring goes on there, and then the front spring overlaps onto the back spring on there. And then you give it like a slight 45-degree angle on there, just like this one. And then that angle is aided by the O-ring. Just keeps it up. Just tucks behind that screw there. And then we're just gonna bolt that down, put the contact screw in, tighten everything up. Just tightening that back spring on there, and then we're good to go. Okay guys, so before I tune this machine, I really quickly want to explain how a coil machine works. This won't take long at all, but it's going to make the rest of this video make so much more sense. So first of all, we attach a clip cord to the back of the machine. Power needs to travel through the machine to complete a circuit. When power travels through the copper coils, hence the name coil machine, these essentially become magnets. Because the armature bar is metal, the now magnets pull the armature bar towards them, pulling it downwards. This armature bar would have a needle fixed to it by a rubber grommet, so therefore the needle will move downwards with the armature bar and obviously into the skin. But what also happens when the armature bar moves downwards is it pulls the front spring with it too. This makes a gap between the front spring and the contact screw. So it's at this very moment that the circuit is broken. So if the circuit is broken, the coils no longer become magnets. And because they're no longer magnets, they stop pulling the armature bar down. So this is where the back spring does its job, because the back spring then pulls the armature bar back up to its original resting position before the power was added. So as the armature bar returns to its resting position, the front spring then makes contact again with the contact screw, and at that very moment the circuit is complete again and the whole process continues. So let's start from the very first step of tuning our machine. So the very first thing we do is connect the clip cord and plug into a power supply. I like to turn the power right down to 1 volt, then stand on the foot pedal to run the machine. Now at 1 volt the machine will most likely not do anything, so then I gradually start to increase the voltage. As the voltage is increased, the armature bar will start to move, but before it actually makes contact with the coil, it will hover just above them. Now this is known as ghosting. It does this because the magnets are pulling the armature bar, but because the volts are so low, it means the magnetic pull is low as well. So although they're pulling the armature bar down, they're just not powerful enough to pull it all the way down to make contact. So we increase the voltage until the coils have enough magnetic pull to actually make the armature bar make contact with the coil. When this happens, you'll hear that distinctive click, which results in that beautiful coil machine sound. Now when I hear the click, I usually give the machine just an extra volt or so, just so the machine's not struggling, bringing that armature bar down. So now we've set the power supply and the armature bar's moving nice and easily up and down. So just a little bit of added information whilst we're talking about power. Everything I've just covered about starting the volts low and increasing them until the machine kicks in. This is the reason why I can't tell someone what voltage to set their coil machine at. So sometimes I get messages and they say, you know, what's the right voltage for lining, what's the right voltage for shading? Because it just depends on when their machine kicks in. So some machines run at really low volts and some run a lot higher. Essentially, it's really pointless asking what power setting should be to run a coil machine. It's different with a rotary machine, but I'll not get into rotaries in this video. But I'll put a card up on the screen, the differences between coil and rotary, if you want to check that out. And you can watch that after this video. Okay, so we've set our power and our armature bar is moving up and down. Now, one complete cycle of down and up, again, is known as the cycles per second, or the CPS. Now, this can be seen on the digital power supply under the Hertz reading. Some power supplies actually have a display which is labelled CPS, but lots of them say Hertz. So let's, for example, say you're running your machine and the power supply displays 90 Hertz. Then that would mean your armature bar is moving your needle down and up at 90 times per second. Now the Hertz reading only gives you CPS for a coil machine. If you run a rotary, the Hertz reading won't be the CPS because rotaries work different. So knowing your CPS is really, really important when tuning your machine. Now I'm going to explain what CPS you should be aiming for a liner machine. Now generally speaking, this is a rough ballpark figure and some people go faster than this and some people go slower, but the average CPS for lining is around 130 cycles per second. And that's what we're going to be aiming for tuning our machine in this video. So now we know what CPS is, we can start to understand how and why we make certain adjustments to the machine. So we know the time it takes the armature bar to travel down and up makes the CPS. Now we need to focus just above this and look at the gap between the front spring and the contact screw. Because if the front spring only has a short distance to travel down and back up again, then it's going to be making contact with the contact screw a lot quicker to make the circuit again. Whereas if the contact screw was further away, the front spring will take a lot longer to complete the cycle because it has to travel further. This in turn results in the CPS getting lower the further away the screw is and faster the closer the screw is. So to recap, the shorter the gap between the front spring and the contact screw results in a higher CPS. So basically a faster running machine. And the bigger the gap results in a lower CPS or a slower running machine. So just making small adjustments, screwing the contact screw down and up will have a direct effect on how fast or slow your machine will run. And I'll quickly jump to an example of this so you can actually see this in action and you'll be able to actually hear the machine speed up and slow down as we turn the screw. So here's some added bonus information. There's an old rule of thumb that tattooists used to, and some still do, set their machines using a dime or a quarter, or if you're in the UK, a pound or a penny. Now the thickness of the coins were roughly the right size gap to put your machine's CPS in the right ballpark to run as a liner or as a shader. So basically the thicker coin would set the machine as a shader and the thinner coin would set the machine as a liner. And some people think that the coin had something to do with the actual setting of the machine, but all it did was basically pose as a rough measurement guide to set the gap. Okay, so now we know we turn the contact screw up and down, it will make our machine run faster or slower. So all we have to do is run the machine, check the hertz on the power supply, turn the contact screw until the hertz read 130, and that's our machine all tuned up, right? Wrong. It is true that you do set the CPS by adjusting the contact screw and watching the hertz on the display on the power supply, but there is an extra level of tuning that needs to be completed if you want your machine to run flawlessly. And this next step is a step that not many people seem to understand or even know about, but now I'm going to show you so you fully understand it. So for this next step, we need to go back to the power supply and look at the duty display. Now this reading tells you the percentage of time that the tattoo machine is actually on during a cycle. Remember we spoke about when the front spring is in contact with the screw? Well, that's when the machine is considered on because the circuit has been made. As soon as the circuit is broken, meaning the contact screw and spring are no longer in contact together, then the machine is considered off. Now a decent duty reading for a machine to be running at will be 45%. This will be considered as a good duty. But we don't just want good, guys. We want perfection. So the sweet spot that we're going to be aiming for in this video is 50% duty. If we can have our machine running at 130 cycles per second and our duty at 50%, then I'd consider that machine to be running absolutely perfect. So why are we aiming for 50% duty? Well, the reason for this is because if the duty is below 50%, it means the machine is more off than on during a cycle. So this means the front spring is spending more time away from the contact screw than it's spending on it, which also means the needle is spending more time in the skin during every cycle, which ultimately means as you're pulling a line, the needle isn't coming back to the tube for ink more evenly. So this results in obviously a poor line and possible damage to the skin. Now, if the duty is higher than 50%, it means the machine is more on than off during a cycle, which basically means the front spring and contact screw are spending more time together than apart during the cycle, which means the needle is spending more time in the tube than in the skin. And again, this results in a weak or poor quality line. So let's just do a really quick recap. We know the CPS that we're aiming for, and we know how to set it with the contact screw. We know the duty we need. So now we need to know is how to set the duty. And I'm going to show you. So let's say we've got our machine now, we've turned the volts up, the armature bar clicked in, we've adjusted the contact screw, so the machine's running at 130 cycles per second, but our duty is way out and reads at 30%. This means our machine is only on 30% of the time during a cycle, meaning that the front spring and contact screw need to be making contact with each other an extra 20% to make up our duty that we're aiming for that 50% sweet spot. We don't want to close the gap anymore that we've already set because that will mess up our CPS that we've just set. So to adjust the duty, we need to make an adjustment to the machine, which is going to make the front spring be in contact with the contact screw more during the cycle. And we do this by putting an ever so slight bend on the back spring, which will bend all of the armature bar and the front spring towards the contact screw. Because of this slight bend, the front spring will now return quicker to the contact screw during the cycle because the back spring is applying more pressure to it. To make this bend, we loosen the nut of the back spring, we swing it out, apply a slight pressure to bend it, and I mean a really slight pressure, and then we swing it back in place. Then we tighten the nut back down and run the machine again and check the duty. Now, if the duty goes up, let's for example, you've just put that pressure on the back spring and your duty's gone up to 40%, then you know you're heading in the right direction, and then you have to repeat the steps, swinging it out again and applying a little bit more pressure until your duty eventually rises to 50%. Now, if your duty is higher than 50%, the front spring and contact screw are in contact too much during a cycle. So we need to repeat the steps of swinging it out like before, but this time we bend the back spring downwards. Then we swing it back, lock it down and run the machine, and we keep making these adjustments until we hit 50% duty or as close as we possibly can get to it. Once the duty is set, you might need to make a tiny adjustment to the contact screw if the CPS has dropped or gained slightly, but this should be really minimal at this stage of the tune-in. Then all we need to do is just tighten up the screw to stop the contact screw moving whilst the machine's running. So now you've got your CPS and your duty set. They're both running in sync with each other. Congratulations, guys. You've just tuned your coil machine. Now here's a really important point, and it goes back to the thing I mentioned quite a lot in my videos about having quality equipment, quality machines. And a good quality machine from a reputable machine builder should tune up pretty easy and not give you much of a problem. However, cheap machines from eBay, Amazon, which are clones from China, will most likely drive you actually insane trying to tune them. I've tried tuning a Chinese machine before, and it was literally almost impossible to match the CPS with the duty. They tend to run really erratically. The CPS goes up and down randomly on them. The duty won't go above 30% without the machine dying. They heat up after about 10 minutes of use. They just come with a whole host of problems relating to cheap capacitors, plastic coil centers, and just to name a few. There's a whole host of problems with them. So don't be surprised if you do have one of these and you can't tune it. So guys, so you've spent all this time watching this video, which I really appreciate, and it wouldn't be fair to just leave and not show you the machine running. So I'm gonna jump into that now and show you a nice little clip of it. And this machine is fully tuned up, raring to go, and for me, it's an absolute thing of beauty. Thank you so much for watching this video, guys. If you did like it, please hit that thumbs up button. Don't forget to subscribe to my channel. Really important, hit the notification bell. Stay up to date with all my latest uploads, and I'll see you in the next one. Cheers, guys.